Like at lunchtime, you were. All right, guys, welcome. Justin, the B team of the VMware leaders. Oh, John, here, I'll unlock it for you. You already got it. Sorry. David and Ryan are at the VMware leader conference. Yeah, we did a great job of scheduling and scheduled a meeting over the top of that. So two of them are out, and Colleen is working 80-hour weeks. So told her to take the night off. So David has a issue with Active Directory. He wants to talk to us about your details.
So I didn't know this, but when you add someone to the domain admin user group and remove that permission, Active Directory doesn't remove all of the admin rights. It'll actually leave some in place. And he goes into discussing how that works and knows a lot more about it than I do.
Hi, everyone. Sorry I couldn't be with you guys tonight. I had to fly out to a conference today, so I really was looking forward to hearing Caleb talk about Docker and containers. And I will definitely look forward to the recording, assuming that all goes as planned. I wanted to do a quick video on something I was going to present on in person regarding the admin count attribute within Active Directory and admin SD holder process that runs within Active Directory. This attribute was something that I learned about back in 2016 while I was at a conference with somebody I met there, Carl Webster. Very smart guy when it comes to pretty much anything I talk to him about, but one of his big focuses is Active Directory. And he does health checks and migration and things for very large corporations for Active Directory. And he's mentioned several times that when he goes in, one of the biggest issues he ever sees is the admin count being set to 1. And what does that mean? You are probably asking yourself. So whenever somebody gets added to a privileged group, so domain admins, printer operators, account operators, there's a whole long list of groups that are considered protected groups. And there's some lists I'll show here in just a little bit that show all those groups, or at least the link to those. But admin SD holder is a process that runs every hour. It looks for accounts or objects, so it could be a group or a user. And if it finds that set to 1, it takes the permissions, copies them off, and disables inheritance. So where that becomes a problem is when you remove said user or group from a privileged group. It does not remove that admin count equals 1 flag or attribute. So when the admin SD holder runs again, it's going to reset those permissions back to whatever group it was in before, because that's the permissions that's supposed to be on that user. Now, one may think that is dumb. I mean, if I go in and I change it, I remove somebody from that group, it's because they're supposed to be removed from that group. However, this is by design that it's set up this way. Now, the purpose of it is so that if somebody at a lower level OU removes something or changes something on that user, that the permissions from the higher level, so the protected group, gets reapplied. However, it does cause some problems. So whenever you remove somebody from those groups, you need to make sure to go in and do some cleanup to, 1, clear that attribute, and 2, to re-enable inheritance on that object. Now, another big reason for changing that, other than just the permissions part, where it became an issue, my understanding from talking to Carl is that in 2016 it's been corrected where the following can't happen. But if you're on a domain level older than 2016, or if somebody was set prior to that, it may not be fixed for them even if they're removed. So say you had a user, they got added to the domain admin group, and admin SD holder ran, set that attribute flag to 1, copied the permissions off. You go in and remove that user from that group, say it's domain admins. That user could then go in, log into Active Directory, go to their own user, modify it, and add themselves to, say, enterprise admins, which you can't do unless you're a domain admin, but it would allow them to do that because of admin SD holder ran and gave them their permissions back. So it's not an instant thing. It's not something where you go and remove them from the group and they instantly are able to go in and do that. But every hour, admin SD holder runs. And it's not on the hour, it's just every hour. So everybody's environment's different. So you don't know exactly when it runs, which complicates this process a little bit of cleaning it up. Because if it runs in the middle of you cleaning it up, you've got to re-clean up. So as soon as that runs, that user has that permissions back and can give themselves elevated permissions. I was hoping to be able to demo this. However, my environment, my lab is 2016, and I've been unable to duplicate it. And I would probably also have to wait the hour, or however long, until admin SD holder runs, because I'm not sure how to force it to run. So anyway, so what do you do about it? Now, first, I'll show you the attribute. If you don't know how to see attribute editor in users and computers, to see that you have to go up to view and advanced features, and then that turns on some extra tabs, including attribute editor. So you can see this non-admin, admin count is set to 0 or nothing, not set, because it's not a member of a privileged group. If we look at an admin user I created, and they're part of the admin domain admins, like attribute editor, admin count is set to 1. And we can see if I take this user out of admins, apply, was just for extra. See, admin count 1 is still there. So some issues that he talked about this causing, and I've also, I did some quick research on this to refresh my memory on all of this before doing the video. A member that somebody who has admin count equals 1, their account cannot be managed by, say, somebody in the help desk users group, which messes up, somebody who needs to go in and reset somebody's password. They're not able to do it. It can only be done by a domain admin. So that flag, if you're having that issue, which we've had at Beacon in the past, and this resolved that issue for us. We were changing permissions and all kinds of stuff and could never get it to work. And it came down to this admin count flag or attribute. So if you're having that issue where certain people can't reset others' passwords, well, that's part of that. So let me go ahead and pull a couple links over here, or articles on that. So this one on TechNet, I'll see if I can put this in larger into the video here in a minute when I'm finished. But this one goes into talking about how to find those users. So you don't have to go to every object and check that attribute that I was showing you. There is a PowerShell script to do that, and then there's PowerShell scripts to fix it as well. But you can see it also disables inheritance. They talk about that in here. So, right, but they don't have the scripts in here, but they talk to you about how to fix it. But here's an article. This one's a little older, so that one is from 2018. This one's actually from 2016. But it goes in, and this one actually talks about the help desk issue here. But this one has two scripts within this blog from I can't remember his name. David Brett, I think. He goes by Bretty. Brett, yeah. Anyways, the first script just goes through, and you have to edit where you want the CSV file to be put. It's going to export it in a CSV, and then also you got to go in here and set your search space. And then the second one will actually go through, and of course you got to set your search space on it here, where you want to search at, and that might be it. Actually, you may not have to change that. I don't remember. I haven't actually run this script because I actually do it a little bit different with a different script, a one-liner, but this one's much more cleaner, or much more clean, and exports it to a file so you can do better documentation and stuff. So it's actually better the way I did it. There's more information there. It talks about this article on admin SD holder. The problem with this article, it was written back in 2008, 2009. It talks about 2016, but it's in the September 2009 group, so it's been edited a little bit, but there's some default protected groups, but it only goes up to 2008. That's where these servers or groups are. Yeah, so I don't know if it didn't change after 2008 or what, but anyways, you can look up easy enough to see what other ones are protected. But I've talked a little bit about Carl Webster. He does have a website that has some really good scripts. If you're not familiar with this site, got some scripts and utilities. He basically came up with a framework for scripting to document your environment. And this is Active Directory. There's lots of different things you can see on his website. So if you go to carlwebster.com/downloads, or just search for Carl Webster documentation scripts, you're going to find this. He's got some great documentation scripts out there. You can output to HTML, you can output to Excel, you can output to PDF, a few other things. You can read the guides on them, but they're pretty simple to run, document your environment pretty well. I run these when we have audits. So when the auditors come in, I just run these, hand them the documentation, and it's all up to date. So they're really good. And another reason why I bring up the Active Directory one, and I don't remember if it's the first option or the second, or it may be both, but at least one of them has a check in it. I think it's the health check, actually, that goes through and looks for the admin count equals 1, and it puts that as part of its report that it exports. But you can see there's lots of different scripts out here, and there is a VMware one as well for documenting your vSphere implementation. So, and then you can see there's a few others for some other stuff. And it's not all documentation scripts. That's just what a good portion of them are. You see he's got some for Bart Jacobs tools that are out there for doing some different things as well. So anyways, so if you haven't checked out his scripts, I would do so if I were you, and take a look and see how they can help you in your environment. You can also learn a lot about PowerShell by looking to see how he how he does things. He's put stuff in Excel, he's put stuff in Word, then so what he actually does, he uses Office to create PDFs. You don't have to have Office, but if you want to create a PDF, you do have to use since that functionality within Word to create the PDF documents. There's anything else? There was one other item I wanted to present on tonight. I didn't quite get to, and I'm not going to create a video at this point for it tonight, but later meeting, I'll get to it. Carl Webster, when I was at a meeting with him a couple weeks ago, or a conference, talked about the way that you can speed up your replication process between domain controllers. So I need to explore it a little bit. He gave me some resources to look at, test out. Super easy to do, supposedly, but stay tuned. I'll go into more details later. All right, if you guys have any questions, hit me up on Slack. And if I don't know the answer, I can definitely get with Carl and see if he knows. And I look forward to seeing you guys next month at our March 20th, I believe. But I'm sure Justin already mentioned that. All right, talk to you guys later.
That was David live from his daughter's bedroom. All right, make sure you're on. You're on.
Cool.
Let me grab the PowerPoints. Oh, there it is. Yay.
Yep. Hey, welcome. So that was the video admin topic. So we kind of jumped around on our agenda. So we're going to have Caleb present on Docker. He's been so nice and kind to donate his time to make us all masters, and we're all going to roll this out production tomorrow, right? Right? You want to set up his AirPlay?
Let's gotta make a full screen for you. Blue. All right, there you go. Oh.
Sound.
There you go.
Everybody hear me okay? All right. Well, today, obviously, we're going to talk about what is Docker and why it's so awesome. At least that's my opinion. So actually, first off, who here has actually used Docker before? A small handful of people. Is anybody here consider themselves a developer at all? Okay. Just kind of laying out the room. All right, so Docker, it's an open source tool designed to create, deploy, and run applications using containers. And Linux containers, Windows containers. Docker didn't invent Linux containers, but they did really bring them mainstream. Back in 2013, they released their first version, and since then, it's had major adoption across huge IT companies around the world. So a Linux container is essentially a set of processes that's isolated from the rest of the system. And we'll get to how that differs from a virtual machine in just a minute. Containers are portable and consistent across different platforms. They share the underlying operating system kernel, which is very different than a VM. And obviously, they can be ran within a virtual machine or on bare metal. So the differences between virtualization and containers. Obviously, you all know on the left, we have virtualization. You have a bunch of apps running in guest operating systems on top of a hypervisor, on top of a host operating system. And then on the right, we have containers, where we have a bunch of applications, the supporting files and runtimes that run the applications, but there are no other operating systems except the one it's running on. It uses that host operating system's kernel, and the processes are isolated. So obviously, virtualization can be very heavyweight because you're running a bunch of copies of operating systems. but it does offer you very tight isolation, full isolation, not just process. And so containers, obviously lightweight, uses the underlying kernel. Like I said, it's just process isolation. So this is for Linux. And so like I run a Mac, and I think a lot of people run Windows, and obviously that's not Linux. So what those systems have to do is run a virtual machine. So what Docker does is very nicely, it hides that from the end user. And on Mac specifically, it uses HyperKit, which is a super lightweight native hypervisor framework for OS X. And I think on Windows, it obviously uses Hyper-V. And like I said, the VM is abstracted from the user. As an end user on the Mac, you really don't even realize you're running in a virtual machine. So tonight we're going to cover several of the key concepts of the Docker architecture. The ones we're going to touch on are Docker files, images, containers, tags, registries, layers, and volumes. Now, like as a new Docker user, it's extremely easy to get at least the first three really mixed up and really not know what they are. So we will hopefully solve that mystery. So first off is the Docker file. That's where you start when you want to use Docker. So Docker file is the instructions for assembling images, kind of like a recipe you put together. They consist of a series of commands in a file. Those commands can be things like shell commands. You can set environment variables. You can copy files from your local system into the image. You can build your applications and pretty much anything you can do in shell. So what they can do is you can start from a base image. And those can be things like Ubuntu or Debian, or maybe your runtimes like Node or Java or PHP, just totally depending on what kind of application it's going to be used for. So here is an example of a very simple Docker file. This file would just literally be called Docker file, no extension, anything. You can change the name, you can add extensions, but by default it's just called Docker file. So the first line is the base image I'm using. This image's name is Node, and by default it pulls images from a site Docker Hub. And I think this version is like version 11, whatever the newest version of Node is. The second line here, I'm setting my current directory to /app within the image. I'm going to copy all the files in my current context, whatever directory I'm in on my local system, and copy all those files into this image. Afterwards, I'm going to, in this case, just run npm install, something you would do in a Node.js application. But you can do anything here to build whatever application you need. Like if you have a Java app, you can compile it. PHP, you can install your composer dependencies, whatever you need to do to compile your application. In this case, it is a web app, so it's going to be exposing port 3000 to listen on. And the last line here is the command to run whenever this container starts. In general, you want to run one process in a container. There are some ways around that, but the best practice is to just run one thing per container. So we'll show here, I can take that Docker file and I can build it into an image. So you see here my directory, I have a couple very simple Node.js application files and then my Docker file. To build the image, I just run docker build in the current directory. That goes through, runs all 6 of those commands. An npm install obviously takes forever. You're downloading half the internet. And after that's done, we expose the port. We run a node. So, and you can see here that it created the image, successfully built 16BA, whatever. That's the name of the image we just created. And we'll get to how to actually name that nicely in just a minute. So, okay, we created an image. We built it from a Docker file. That image is now a totally self-contained, runnable application. It has my code already built. It has the node runtime in there. And it's composed of multiple files called layers, which we'll also get to in a minute. That's a huge component of Docker. So what can we do with that image we just created? Well, we can start it and run a container. We can do that with our custom built image. We can also run images from the community. I can run Redis or Node or a PHP app, MySQL, whatever. It's almost all out there on Docker Hub. You can extend images with other images, and you can distribute these images. So I'll show you in a minute that I can take this application, put it up on the internet for anybody else to pull down and run. So let's take that image we just created and run it. So this command, you see docker run -d puts it in the background, so it's not tying up my console. -p, you saw that we exposed port 3000 in the image. I'm mapping the containers port 3000 to my local systems port 3111, and I give it the name of the image we just created. And you can see that big long string there is the ID of the container we just spun up. And now I can actually go to curl. I can curl my localhost on port 3111, and I get a response. Hello, container world. So in this case, I didn't have to have Node installed on my system whatsoever. It's all self-contained within that image and container. So the image with the name 16BA7 whatever, not friendly at all. So what we can do is we can tag an image. So we can do that during the build process or after the image is already built. And you can use tags for a ton of different things, and they can be really whatever you want them to be. The general convention is to have a nice, pretty name for kind of like repository, and then you can have a colon, and by default, it's latest if you don't specify a colon tag, but you can do whatever you want after that colon. So you can use version numbers, you can use git commit hashes, literally anything. So let's make that image just a little bit nicer. So we take that image we just created, 16BA, we tag it with the nice name node hello world. Now, like right now, those two images, 16BA and node hello world, are exactly the same. They are just tagged with two different names, kind of like an alias, one to the other. You can see here I did the same thing we did last time, except I used node hello world as the image name. It started a container, and just like before, I can curl my local system and we get the same response. Okay, so we started that container from an image on my local system. That doesn't really do us a whole lot of good because it's only on this system here. I can't deploy it to production. I can't share it with anybody. So how can we actually share that with the rest of the world or in our company? So we use something called registries. And registries are the place where Docker stores these images. On my system right now, there is a registry. That's how it manages images on local systems. You can have registries on any system over the internet. It uses a simple REST API to manage it. You can host public or private repositories, requiring authentication or not. And obviously you can host your own, and you can even host a Docker registry running in Docker, which is awesome. So we'll show here that in order to get this up to, let's say, Docker Hub, which is just a free public registry, I have to tag it with the appropriate tag. So Caleb Birch is my Docker Hub username, and I created a repo on it called Docker Hello World. And so if I tag that image on my local system with the appropriate tag, Caleb Birch Docker Hello World, I can then push that image up to Docker Hub. And you can see here, like pushing and pulling is the way to move images around registries. So you can see here, it pushed all those layers one by one up to Docker Hub. And now literally anybody in the world can go and just say, Docker run Caleb Birch Docker Hello World, and they will run that exact application that we just did. Pretty cool. Okay, so a very fundamental piece of all this is the concept of layers. Layers are the building blocks for these images and containers. Now we just built images. Now those are a bunch of read-only layers. Obviously you can't do anything with an image until you spin it up into a container. And so a container, then when we run it, is essentially those images layers with a small writable layer just sitting on top of it. Each layer is generated by a command in the Docker file. So before, we saw our Docker file with those 6 commands. Each one corresponded to a layer. So our image has 6 layers. Actually, plus the first one was using the node base image. So that is one layer that came from a bunch of other layers. The purpose of this, the layer system, is that it optimizes the build performance and the storage utilization on your registries and on your running systems. So first off, we'll talk about how it optimizes build speed. So in between building our images, there's really no need to remake these layers that don't change. And some of them can take quite a while. We saw the npm install, this was a tiny application, and it took 10 to 15 seconds. On a production real world application, that's going to take a minute or two. And so if you can cache that because none of your dependencies changed or your dependency requirements changed, then that can be a huge time saver. So you can also kind of strategically write your Docker files to combine commands to create very cacheable layers. And that's definitely a goal when you're writing those Docker files. And so say we have 2 images that use that node base image. I don't have to re-download that layer because they are literally identical across those images. So layers are shared across different images on your system. So let's look at an example here. If I just do a Docker pull node, let's say I don't have the node image on my system whatsoever. This is just going to pull down the node image from Docker Hub. This is the first time I've pulled it down, and you can see here that it has 8 layers, and all 8 of them had to be downloaded over the internet to my system. Now let's say I come back and I want to pull down a different version of that node image. I want to use version 10 this time. The first one was version 11. You can see here that 6 of the 8 layers actually already existed on my system. And all I had to do was download 2 layers. Just really the difference between node version 11 and node version 10. And this time it took 10 seconds, I think, what I had before. To do that last time was about a minute on my home internet. This time 10 seconds. So that's a major difference there. Same thing. Literally, I want to use version 8 this time. 6 layers already exist. 2 have to be pulled. The difference between node version 11 and node version 8. And that's 10 seconds. Yeah.
Just trying to keep up with the concepts a little bit.
Uh-huh.
And this caching element. So when you have your Docker file and you're running those commands to pull images from
Docker Hub.
Docker Hub,
Yep.
Aren't those dependencies kind of contained within themselves in that container? And with that, like, how does the caching work with that? Because this looks like you're just pulling that image into your central system versus into a container. Is that how that's working, or am I missing?
Well, you're pulling it into an image. You use an image.
This is an image.
Yeah, this is just an image. And now you use an image to start a container. So like I said, to keep Docker files, images, and containers like straight and what they actually do when you're first starting out is really difficult. So a Docker file is a recipe how to create an image. An image is used to run a container. And again, all that's really different between an image and a container. So an image is just files. It's not doing anything. A bunch of read-only layers. And when I want to run a container, I take a very small writable layer and stick it on top and give it some CPU and memory and that. And like that's the only difference. And I'll show a cool example of that in just a minute. Did that answer the question?
Yes, it is.
Okay. Yeah, another question.
Kind of going around,
Uh-huh.
roundabout. So is it easy to think of as an image is more like almost like an ISO file?
Right. It can't do anything. It's just a file.
Correct.
You can't run. It's not running an application. And
Right.
then when you take that ISO and you mount it and like run something from it, then that's
what
the
makes
container.
it the container.
Yeah.
Okay.
Yep. Any other questions before we go on? Yeah.
Well, conceptually, I don't know if this would help, but what
Mhm.
I hear you say conceptually is that the container, because it's an isolated process, is what gives you the runtime environment. When you think of an ISO or an executable on an ISO, the OS is running that. The container is different because you have to have somebody isolating and executing. That's where you're saying you're adding that layer for the execution. Is that a way to, clean way to phrase it?
I think so. And yeah, I think, well, I'll get to a slide that might show something in a minute that might kind of clear some of that up. So we'll move on from here. The second way you optimize layers help optimize this system is that you don't have to store identical layers across different images. So like identical layers used on multiple images, totally different applications. They may share some base layers that are the same. And one really cool thing is that the same concept applies to running containers. So since an image is just, since a container is just a running image, those layers are shared across running containers. So you can see here, I took a bunch of instances of that application we just created, and there's like 8 of them there. And Docker PS-S shows all my running containers and the size they are. And so that virtual 900 meg, that's the size of my image in all its layers. And the 0 byte size is that tiny writable layer. And so since I just started it up and like nothing is actually being written into that container, it's 0 bytes. And that's 0 bytes across 8 instances. If I fired up 1,000 instances, it would still use 900 meg of space, which is pretty cool. So that makes this extremely scalable. So then you're just, allocating your CPU and your memory, and there are tools to do that in production, which that goes way beyond this, like using Kubernetes and Docker Swarm and things like that. Okay, any questions on that before we go on? Okay, so we have all these layers in that small writable layer. But if I were to shut down those containers, all that data would be gone in that writable layer. It is not meant to be persisted. Now, how to actually use persistent data in Docker is by the use of volumes. And you can do volumes quite a few different ways. You can mount volumes to a local system. So say I wanted to mount a directory on my MacBook to a directory in a running container. I can do that. And there's a ton of different storage options for volumes. NFS, obviously your local system, tons of cloud storage options. There's a bunch of plugins for pretty much any kind of volume storage you need. So just a really quick example of how you would use volumes. So say I want to run MySQL in Docker. Obviously, I don't want to lose that data if I shut down the container. So I create a volume for it. I give it a name of MySQL data. And when I run that image, Docker run -v, I give it the name of the volume I want to use, colon, what directory I want to mount it within that container. And so the MySQL image wants barlib MySQL as the data directory. So if I were to totally kill that container, delete everything about it except that volume, later I could come back, mount the same volume in a different container, and all my data would still be there. The same goes for the second example, where maybe I just want to mount in my home directory /data /MySQL 8. That's just the directory on my system. I can mount it in the same place I did before, varlib MySQL, and all the data will be here on my local system. And then I can access it at the same time. And that's one way we can do like local development in real time using Docker. So I'm coding a Node application, and it's in my home directory /projects /app1. I can mount that directory into a container. I don't have to actually have the Node runtime on my system running, but my code will be mapped into that container that does have the Node runtime, and it can be running, it can be building, it can be running tests, and all that. Now, again, you don't want to do that in production. It doesn't make sense to have your data mapped that way. You're using things like network attached storage and all that. That's not really my expertise, running this stuff there, but I know you do not want to do this. You don't want to map it to your local system. Okay, so that covered like some of the basic concepts. There are other things like networking, which you can do quite a bit of networking stuff in Docker, but that's not my area of expertise in this case. So we'll go over some quick use cases for Docker. So one of the first ones, which is really, really handy in the development world, you can run multiple environments without conflicting with each other. So like common problem, legacy application requires a super old version of whatever, like PHP or MySQL, and my other apps on my system aren't compatible with that at all. So the solution is to isolate it and run it in a container. So in this case, I just have a simple script here that will run two containers. And in this example, they're both mapped to the same directory with the same code that really just prints a hello world. One's going to be running on port 8053, one on port 8072. One of them is running PHP 5.3 and the other PHP 7.2. Totally different. They would conflict with each other pretty quick. So I run that. It fires up two different containers. let's curl to 8053, and I should have it run in PHP 5.3. Do the same thing from 8072. And it returned from PHP 7.2. So both of those things are running on my system. No conflicts whatsoever. Now I can do kind of the same thing with another version, but maybe just like a CLI script or something. So I just want to run a PHP 7.0 script. It didn't exist on my local system yet. Well, you see 4 layers actually existed that were already shared with PHP 5.3 and 5.7. It needs to pull down 4 more that are specific to the 7.0 runtime. It downloaded those, it started the container, it ran PHP-V and returned, PHP 7.0. So, yeah.
So that's awesome. I mean, it's awesome that you can create different dependencies.
Mm-hmm.
That's awesome. You can basically specify which versions you want depending on what your dependency needs are.
Yep.
Now, when you're building these containers, I guess I'm also trying to wrap my head around what's being pointed here. Is the application that you're running that might need that dependency in another container and you're mapping those containers together, or are they all in the same one? So let's say it's a node application that has React and PHP or MongoDB or whatever. Would those kind of be contained together? Just depending on
You could technically do it that way, but I wouldn't. Like I said, you want to have one process running in a container. That's like the ideal, perfect way to do that. Now there are ways to link them all together. I'll show near the end this example with Docker Compose. You can do that in your local system. Stuff like Kubernetes and Docker Swarm is how you would do that in like a big production environment, and they do that really well. Essentially, you can take containers, run them side by side in things called pods, and they act like they are on the same system. So calling something from localhost will be able to reach across containers. So that's how you would potentially like have a node application that's fronted by Nginx. So Nginx is in one container, node is running on another container. They're sitting side by side, and they act like they are the same system at that point.
So when you're developing these containers, typically you're just working with one of those pieces.
Yes.
And then later you're linking them.
Yeah. Yeah. It's like when we're developing, I don't necessarily need to front it with Nginx or the production ready stuff. And also in development, there's probably a little more leeway with the running one process per container. And so in dev environment, yeah, I might actually be running Nginx and Node in the same container. Then when we get to production, I'll split those out.
Got
it. Yeah. Any other questions? Okay. Okay, so another really common problem is the works on my machine problem. Like everybody has that issue. So what Docker does is it bundles all the dependencies you need for the entire runtime of the application in that image. Usually the works on my machine problem is some dependency is not installed somewhere. And you go to run it, it crashes, you have no idea why. This definitely solves that. And so you can bundle things, like I said, with dependencies. You can bundle environment configuration in an image. And one great thing about that is that the code, your application, and the runtime is deployed atomically. So like say you wanted to, at the same time you deploy a piece of code, also upgrade Node from version 10 to version 11. Like since they are bundled together, they are upgraded at the exact same time. So in this case, I have an example of a PHP 7.2 CLI app This is a Docker file we're looking at here. I start with my PHP 7.2 base image. I can run shell scripts, so I'm installing a bunch of system dependencies and stuff from ImageMagick and a bunch of stuff that would be really nasty to have to install on a system, make sure it's there, and then run it. So I run all that. I'm running PECL commands to install the Redis runtime for PHP, Xdebug, ImageMagick, and I set those up. I copy my files from my local system into the image, and I wanted to run PHP index.php. And so we talked about before the benefits of caching in these layers. So this right here will create 5 layers. And you can see the first build time takes about 2 minutes to install those system dependencies. The second time, let's just say I update a piece of like application code. Because I only really changed this layer, this is where I copy my code in, everything above it is totally cached. And the second build time is like less than a second because all it's doing is copying a new file in. Again, all those dependencies live within that image and will be deployed with that image. So that really solves, there is no excuse. There will always be Redis and Xdebug and ImageMagick installed on that system because it is self-contained in that image. All right, actually, any questions on that? Another really cool thing about Docker is the concept of multi-stage builds. This is a fairly new concept, and it helps separate an application's building environment from its running environment. So a lot of times, I have an application that needs compiled, and there are certain tools that need to be there to compile that application. But those tools don't need to be there to actually run it. For example, with Node, or let's say PHP, there's a package manager called Composer. I don't need Composer to be there when I'm actually running it. I just need it to go and install my dependencies for me. So multi-stage builds help that it minimizes image size and also minimizes the security footprint because those tools I had installed to build my application aren't there at runtime. So if we look at an example here, this is an example of a Docker file using multi-stage builds. So this is really separated into 3 different pieces, and I've named them at the top. Like this application here is more like a full stack web app where we have a PHP backend, a Node.js front end, or at least JavaScript front end that's built using Node. The only thing that needs to be there at runtime is PHP because we only use Node to build our assets, and those are just served as static files. So the first one the first stage builds my front end assets. The second stage builds my PHP assets and installs my PHP dependencies. And the third one really copies all the files I've built and installed from both of those stages. And so then in my third stage, I just have everything I need to run the application, not to build it. And so that really ends up with a super lightweight image at the end because you don't have any build tools whatsoever in there. Okay, and so I mentioned earlier Docker Compose. So we've talked about how to run a container and it can run a process. So let's say our little web app needs like a database. Obviously most do. So I want to use MySQL, and let's say we want to use something like Redis for caching. Docker Compose is used to define multi-container applications, the entire environment that I need. So like it says here, you can start dependencies like databases and storage providers and proxies and caches. All those things are on a shared network, and you can create and configure different networks in there. And so with that, we can run an application's entire infrastructure with just one file and one command. So in that example, we have a file. It's just docker-compose YAML file. If I look at that file, you'll see here it has 3 services defined. My application, which would be my little web app. It has Redis defined and MySQL. Each one of those services is going to spawn a container. And you can do things like pass in environment configuration within those. You can specify what ports are going to be mapped to the local system. All this really does is wrap a bunch of Docker run commands up into a really, really nice, easy to use file. So then, if I were to just say Docker Compose up, -D puts it in the background again. I just spun up 3 containers, one for the application, one for Redis, one for MySQL. They are all on the same little virtual Docker network. And each one, like I can use my app, I can reference Redis by just using the DNS name Redis, whatever the service name is. MySQL can be referenced using the name MySQL because they're on the network they created together. So like Docker Compose is really awesome and can be pretty complex and really powerful. I'm sure there are questions maybe on that. Yeah. So this is the way to define the entire environment for your application. And like in development, it's pretty cool because like say I want to run real tests against this. Oh, actually I have one more thing here. And so if you look in Docker PS with that, I have 3 running containers. Yeah. Okay, so say we want to run tests against that application. Like I really want to test if that application can connect to my database and can connect to my Redis server. Like that's really hard if, I have to have MySQL running on my system and Redis running on my system. That's really hard to do automated tests that way and say in like a pipeline, a CI/CD pipeline. Well, Docker, it's so easy to spin up instances of MySQL or anything really. I can create these disposable environments for testing. And so in my automated pipelines, I can have a test that spins up MySQL, runs all my tests, and as soon as it's over, the whole thing just disappears. That container, I didn't map a volume to that container because I really don't care if it sticks around. I just wanted to make sure it could run those tests. And the other really cool thing about this is that when we build an image, let's say I want to get this image out to production, my application really, the image we build and test will be the exact same image that gets pushed up to my production registry, loaded into Kubernetes, and deployed out to the world. And so like it is literally the same file that gets moved around. It's not just application executables and configuration. It is a containerized, bundled, all-in-one application from start to test to production. So extremely powerful there. Okay, so I touched on Docker Hub earlier, just some little points here about it. Contains thousands and thousands of servers and applications that you can just pull down and run. A lot of these are verified images from the Docker team. You can see little badges next to some that say certified. They have checked those out and ensured that they are secure and that they will work with their systems. Most of them are free for public use, and you can also use Docker Hub to store public images like the one we uploaded earlier. And for a fee, you can host your own private repositories there. And just a list of some of the most popular Docker Hub images that I could just right now say Docker run WordPress. It would pull it down and start an instance of WordPress on my system. Anything that's up there, you can see it's got millions and millions of polls. And so if you're looking for an application, it's probably on Docker Hub. Okay, so there is such a thing as Docker on Windows. You can run all this stuff in a virtual machine on your Windows desktop. And there is now, in the last couple of years, a thing called Windows containers. I'm not really a Windows expert, so I don't know a whole lot about that. I believe like Windows Server 2016 has some native support for running containers. But the community, right now is, since it's been around for Linux and Mac so much longer, you can see the difference in the number of images for Windows and Linux up on Docker Hub. 14,000 as of this afternoon, and 1.5 million for Linux as of this afternoon. But on a Windows desktop, you can run all those Linux images in a virtual machine. And again, you hardly even know it's in a VM because it abstracts it so well. Okay, questions? Yeah.
Well, I don't know if you'd be able to answer this, but can you use the Windows subsystem for Linux to actively interact with Docker on your Windows server? You don't have to have like a separate command line.
I do not know that. You're saying Docker running on Windows server or like a Linux server?
Well, you can use Windows subsystem for Linux.
Yeah.
And I was just wondering if you could interact with it that way instead of using I think you called it the Docker command line.
I don't know. I mean,
It's
maybe,
right. I was just
yeah.
curious.
Yeah, maybe someday they'll be able to run like these Linux containers within the subsystem for Linux. Since I think there is a Linux kernel actually running there, I don't see why in the future it wouldn't work.
I can actually speak to that a little bit because I tried it. I did try it a couple months ago, and it was pretty gimped. So the Linux subsystem for Windows is technically Linux, but it's not. It's limited in a lot of ways.
Well, which did you use?
Ubuntu. So I tried installing Docker there, and it didn't work the way I expected. I don't remember exactly what went wrong, but it wasn't playing nice. So
Yeah.
installing on Windows, it forces you to enable Hyper-V if you have Windows 10. And that's a problem if you run like Workstation, because VMware and Hyper-V don't run together. So what I ended up with is doing was having a VM.
Well, that's not an article. It said it disabled the Hyper-V, but they were all.
Right. And I use Workstation for work. So
Yeah. Yeah. There's nothing
Yep.
stopping you from loading up a Linux VM on your Windows system and installing Linux Docker in that VM and just using it like that.
That's the route I took.
Yeah. Any other questions? Yes.
Can you run it underneath Sigmund?
One more time?
Sigmund?
I don't know. I doubt it. Yeah. Yeah. It has to have the Linux kernel to run. Again, that number, the 14,000 Windows images are actually like made for Windows containers. So I think, again, that only runs on Server 2016. But maybe someday they'll bring it to desktop. Yep.
All of those Windows images
Mm-hmm.
are GUI-less. It's all command line libraries. You can't run anything that requires graphical.
Yeah. Any other questions? Okay. Cool. Thank you.
Thank you.
What's some swag?
See, we've got a messenger bag, a pretty nice VMware mug. It's not a VMUG mug, but it's a VMware mug. There's a hat up there. Oh, and 3 random Amazon gift cards.
We're not sure the balance on it, so
Right.
roulette?
It should be between 10 and 25.
No,
They're leftovers from
They're
our
closed.
Christmas.
They're all closed up.
Yeah, it's for our Christmas giveaway. We did back in. So let them pick. Is that okay, good? If you're called, let them.
I don't know. I really want this VMware back.
Well, I mean, we'll see what happens.
Pick a name.
Select random name. Boom. Dwayne, yay!
Dwayne.
Out of spite.
There's a mug.
I'll have to see if Dave can get us one. And honestly, guys, we have plenty of Fort Wayne VMUG magnets, die-cut stickers, buttons, shirts. They're all for you, all for the taking. Because if you don't take them, I have to carry them home. Tim. Bobby.
Bobby only gets to take something if he brings me his monitor stand.
Who ended up with the Xbox? I forget.
The guy who won the Xbox is not here.
Okay.
So you want Amazon gift card,
Oh, right.
mug. Yeah, well, you should have waited.
Over.
Paul. Got a mug, a hat, or a nice bag. Yep, and wrapping for it. Mm-hmm. Jerry.
Hey.
Your friend that won the Xbox, actually. That's his name.
Maybe I should go work at Frontier.
Leaders aren't eligible, sadly enough. All right, we're down to the man. No one else's bags. Bags look awesome.
All right, and Devin.
Sell it to you for $10.
Beat him up and take his
Yeah, I
lunch.
think I got an extra $10 Amazon gift card around here.
Beat him up and take his lunch money at work.
Correct.
That's it, right?
Yep, that's it.
Okay.
That's all I have.
Better luck next time.
Hey, isn't there's other slides.
More slides.
Hey, look, announcements. So Ben can attest to how well Bishop presents, but supposedly Bishop's going to be presenting on our critical security controls. 2 events that are coming up. The Ohio UserCon, which I'm hoping to go to, is on April 2nd. And then Indy just announced their UserCon for July 16th. The full topics and everything haven't been announced yet, though. Hey, so David got all of our sponsors for the rest of the year. So we should have quarterlies done for the rest of the year. But we need to know, what do you guys talk about? I know, what is it, April we're doing Kubernetes?
Yeah, we're gonna do Kubernetes in April. I'll be talking to that, and that'll be it.
That's Sweetwater? Okay.
Yeah, March is TBA.
Yeah, to be determined. We don't know where that's going to be at yet.
Well, we try to do the third Wednesday of the month is our pattern, and we are like the only user con in the world that meets once a month. That's not an exaggeration.
Correct. Everyone looked at me weird last year when I was at the leadership conference. I was like, hey, we're going to have 12 meetings this year. Huh?
And so if you guys have any input on areas of town, restaurants, meeting rooms, things of that sort, we try to get around different areas of town because it seems like different people come to different ones based on how close it is to their house. So we try to wander around. Last year we did the PowerShell series. The Docker Kubernetes seems to be pretty popular. So, definitely keep in touch with us either personally or on Slack, how we can make these more valuable for you guys and keep people coming.
I think we should make Ben do a presentation on his VX Rails, and he can do vSAN.
Right.
Do like
Well,
a 3-part series. October?
Well, that is one thing to consider. We try to do for the monthly meetings, do a more well thought out presentation, like his awesome presentation was. That was great. From a presenter standpoint too, like having everything gift out, that was awesome. So yeah, hope you're planning.
Very smooth.
I hope you're planning for a conference with that one. That's great. But shorter presentations, anywhere from 10 to 30 minutes. If you've got, something you've found that's cool or a problem you're having, you have a more informal member presentation as well on top of the other one, which we try to do live. And Dave wanted to try this one by video. So yeah.
Yeah, well, his flight got delayed by 5 hours today, so he's probably still on a plane. So go to the next slide because I'm tired of awkwardly entering people's email address. Hey, there's a QR code. If you want to join our Slack, you should scan that and get into our Slack, and then you can talk with us all the time because we talk about weird things. And
I'll put it back up there when we're done.
But that's the last slide. I made it the last slide for a reason.
Oh, yay! Well,
correct. I knew how this was going to go.
Well, I'm going to be right here for a while, so feel free to stick around and introduce yourself, talk about problems you're having, network.
There's more food back there.
Yes, please eat food.
Take it home. I don't want it.
Well, the vultures at my office will eat it tomorrow if we leave it, but feel free to take what you want. All right. Thanks, everyone.
Just kidding. Network rolls, everyone.